least you clearly know what that inequality symbol is and be able to graph it on that number line. When you graph things out on number lines, I don't know how picky your prior year's teachers were, but we don't need to have like that whole number line filled out. It doesn't need to be completely filled out. Just throw out there -3, and I only ask, give me a number to the left and to the right of it, okay? You don't need to, again, throw out there every single tick mark label. You don't need to throw every single tick mark out there. Just give me a number to the left and to the right of that starting point. That's all I ask you. So -3 to the left of it is negative what? 4, and to the right of it is -2. That's all I ask you. Okay. Now from there, what do we got? What are we going to do with that -3? We're going to circle it, right? This is an inequality, so we're going to circle it. And what are we going to do with that circle? Well, remember, those circles either stay open or they close, right? What do? Open or close? Open or close? Thank you. I should be a little more confident there. Yes, they are going to close. Now, what up there tells me it's closing. The or equal to part, right? The little underline there, that's the or equal to part of that. Okay, so these graphs, these inequalities, are either going to stay open, or going to close. And the line underneath of that tells me it's going to be closing. And then remember, we shade, right? We shade either to the left or to the right. So I have not said again what that inequality symbol is. So what is that inequality symbol? What is that inequality symbol? R is what? That is greater than symbol. Correct. That is the greater than symbol. R is greater than or equal to. So which way are we shading? Left or right? We want numbers that are greater than or equal to -3. So we are going to shade to the right. Okay? So what does that again tell us? We want every number out there that's going to be greater than or equal to -3. Those are all solutions here. In our equations we've been doing, linear equations, we can give one solution and that's it. So we can only say like R is exactly 5, and that's the only solution out there. In our quadratic equations we've been doing, we can get at most 2 solutions. And we can get like 5 and -2. We can get 7/2 and -3. We can get 0 and 6. We've seen that. But in inequality, you can get an infinite amount of solutions. Anything that's greater than or equal to -3. Okay? So now let's go to letter B, and then we're going to come back and talk about the interval notation part of things. Okay? 5.5. Again, I'm not looking for a fancy number line. In this instance, 5.5. It's obviously between what 2 numbers? Throw those 2 numbers out there. All right, and I put 5.5 in between those 2 numbers. 5.5 is between 5 and 6, and you can even make those tick marks even go maybe by halves. Even however you want to do your number line, that's fine. And I said go make those tick marks go by halves. All right, I just made my tick marks go by halves. All right, so 5.5 is right there in between. And again, one more time, is that going to stay open or are we going to close it? Right, there is no equal to this time, is there? So that means 5.5 is not part of the solution zone. It's not part of the solution set. What is that symbol then read as? X is what? That's my less than symbol. Okay, that is less than, so we are going to shade which direction? We're going to go to left. We want numbers that are less than 5.5, so we're going to go that to the left. Okay. Now let's come back around and introduce you to interval notation if you've never seen it before. Okay. Interval notation, like I said, it's a little bit of a cleaned up version of using our inequalities. Okay. Inequalities you've been using since about 2nd grade. Okay. So that's where I watch my kids, which are in second grade and fourth grade. That's where you start to learn those. And unfortunately, you learn some bad habits there too about the alligators and crocodiles. Okay, and you might still use the alligators and crocodiles. Okay, so you won't hear me say anything about that, but at this point, all right, we make a transition to using again a little bit more grown-up notation, which is called interval notation. Interval notation is a combination of using parentheses and brackets. Okay, so when do we use when, and how does that just look like? Okay, so when we use interval notation, we're going to read this from left to right. Okay, we're looking at our starting point, which is at what? -3. Okay, so we're going to start this at -3, comma, and then you're going to look at to see where it stops at. Does it stop? And if it doesn't stop, what does that imply we have? Something doesn't stop. Where are we going to? Says, right? We're going to infinity, right? So if something doesn't stop, we just throw down our sayings of infinity. I don't think we've actually ever talked about infinity in this class yet. Here we go. When we say it goes to the right, we're saying it goes to infinity, right? Positive infinity. So what we have here then is the use of, correct, we're using infinity. That's what we mean it says it's going to the right. Forever and ever and ever, it's going to positive infinity. Okay, now we have to throw a parenthesis, brackets, whatever the case is. How do I know to use which one? Okay, it all goes back to the very beginning. Is it open or closed? I like to think of a bracket as like a wall, as something definitive. So when I think of something as like definitive, a wall, something solid, that goes hand in hand with that, or equal to. And because of -3 having that solid piece there, -3 starts off with a bracket. That means -3 is inclusive, -3 is part of the solution, is or equal to. Parenthesis is the opposite of that. Okay? Parenthesis means you can't get to the end of it. Parenthesis means you can't touch the -3. Can you touch infinity? Can you get to infinity? No. So that's what the parenthesis is also implying there with that. So we're going to use a parenthesis as if you just can't quite touch it. Right? I'm not quite touching Eva just yet. Getting close, but not touching her. I'm annoying her, I know. But I haven't touched her yet. So that's what a parenthesis is acting like. All right? That's only two things I'm doing. Okay? That's interval notation here. Parentheses will always be associated with infinity. I will never use that bracket with infinity because you just told me I can't touch infinity, can I? So brackets, it depends on the starting point, I guess. But the infinity will always have a parenthesis, okay? So how about the other one? Where are we starting off at on this one? We always read left to right. Am I starting off at 5.5 on this one? No, where did I start off with on this one? Not infinity. Oh no. This is positive infinity.
Wait, negative?
Right. I'm over here starting off at, one more time, negative infinity. Correct. We always read left to right. Now I heard a lot of you say 5.5. I totally get why you say 5.5. But we always read it from left to right. So where's your graph starting off at? Negative infinity. So I always write it from left to right, and it's starting off at negative infinity. Now, infinity symbol I always write is 2 double zeros. I can't write an 8 on its side. I've never been able to, so I just write 2 double zeros next to each other. Negative infinity, comma, and where did it stop at? 5.5. Okay. Infinity, no matter if it's positive or negative, infinity always gets a parenthesis. Okay, because you can't get to negative infinity. It's always going to get a parenthesis. 5.5, is it solid this time? It was open. So can you actually get to 5.5?
No.
What that open tells me is you can get close to it, but not quite. You just can't get there. You can get to 5.4, 5.49, 5.499, 5.4999, but you can't quite get to 5.5. And when you can't quite get there, That's what we mean by using the parenthesis. The only time you're using a bracket is if it's solid, if it's closed, if it's or equal to. That's what that means. You can actually run right into 5.5, but I can't. Okay? All right. That's what interval notation is. It doesn't get really more crazy than that. It's just a cleaned up version of an inequality symbol. Now, we can't do that, graph it, we can't write the interval notation until x is by itself. So let's solve it out using our solving skills that we've been working on all school year with. On letter C, how are you going to solve for x? First move is division. So we divide by -2 already. X and what is that, 3? It's my Miles 1 students are going through this lesson right now, actually. Okay. I said my solving skills, no matter if it's an equation or it's an equality, our solving skills stay exactly the same. We divide it by -2. There's just one small catch. I'm hearing Eva remind us about it up here. You may not be able to hear it there. When you divide by negative, anybody else? What's that? Flip the inequality, right? So flip the inequality. That's the only thing you got to remember to do with inequalities. When you are multiplying or dividing by some number that is negative, positives doesn't do it. Adding and subtracting doesn't do it. But you're flipping the sign here. You got to flip the inequality. So that's it. That's the only reminder about that. Hopefully that rings a bell from your probably about 7th or 8th grade teachers is where that happens. Okay. And now you're good to go. Now you can graph. Now you can write the interval notation once you have x by itself. 3, open or close. Oh, sorry, I didn't see the, my bad. I didn't see the equal to. I heard close and I didn't see that. My bad. And then less than or greater than, less than, and then write me the interval notation. Okay, let's get into good habits with interval notation, because once we get into domain and range tomorrow, that's primarily what we're going to use is the interval notation. So let's get good at it. Okay, especially if you've never seen it. It's not a difficult style. It's just maybe brand new for you. Okay, left to right. What are we going to have? Negative infinity, comma. We're stopping at 3. Infinity, no matter what it is, gets a parenthesis. 3 depends on what's happening with the 3. 3 is a bracket, isn't it? Okay. Letter D, as we can tell, not even close to being solved for x. So, okay, let's get going here. Got parentheses, right? Got to distribute, got to move it around. Go ahead and do that. Don't have to wait on me. You guys can solve equations. What do we got? 8x plus, plus 12. Keep moving around, solving for x. This is, again, maybe where your calculators might want to come into play. Subtract that 12. This is where the silly mistakes happen. When you subtract that 12, negative 20 minus 12, negative 32. Did not flip the inequality. Subtracting does not change it for me. Only multiplying and dividing by negative, where that sign doesn't change. And finishing off, dividing by 8. And dividing by that 8 still is not going to flip that inequality because I didn't flip my sign. It stayed a -4, didn't it? So I get what? X is greater than -4. At -4, open or close. And again, I said greater than 4, greater than -4. So greater than is going to left or to the right. Correct. And then that's it. Go to our interval notation. We read that always from left to right. So where are we starting off at? This time we're starting off at -4, and we're going to the right, which implies infinity. Again, no matter what we have, infinity, once we throw that down there, parentheses is going to follow it. -4, again, it just depends on the problem. You should know at the very beginning, no matter what we had to start off with, because it was a, there's no equal to there, it's just a greater than symbol. You should have known that we would not use a bracket period on there anyway. So parentheses at -4. There we go. Okay. All right. That's about as crazy as that part's getting. All right. So let's do number 2 down here. Let's jump around. I get a bunch of there. Let's reverse it. Let's do 2A. Given the graph, put it into the other 2 forms. Okay, the idea is no matter what form we give it into as the actual inequality to solve, write me the graph, write me the interval notation. Or given the graph, put it into the notation, write me the inequality notation. However the case is, you should be able to put it into whatever the situation is. So as you look at that graph, you should be able to write out those 2 forms no matter what it is. Whatever you got should be pretty quick. Go ahead and move it to letter B if you haven't done so yet. Check your work with mine. It should be a pretty quick move on that one. These aren't, again, terribly complicated, but it is easy to make a silly mistake here and there if you're not paying attention, say, to the interval notation, especially if this is your first time through. But the inequality part should just be a quick shake off the rest there. Okay. What is that? -1 to infinity, and they're both parentheses, greater than -1. And the other one used the bracket. Okay. Any questions so far? That's hopefully not. If you do, have me yell out. Give me a question here. Let's do a few on the back. All right. Given the interval, make me the graph here. I know some of you like to work ahead, so let's do a couple here on the back that I know we're gonna do. Let's do A. We'll do C, and then we'll do D, and let's throw out G as well. Let's take a look at that first one there. What's -infinity to 4 gonna look like? So I know we're gonna be at 4. I don't care where you put 4 at. And what's 4 gonna have? An open or closed? Open. And then based off the rest of that interval, which way are you going to shade based off the interval notation? Left or right? Because it's starting at -infinity, isn't it? And we're stopping at 4 there. There we go. So we are essentially talking about x is less than 4, isn't it? That implies -infinity is in there, doesn't it? X is less than 4. Now, jumping around here. I said we're going to drop it to C. What's C going to do for us? C stops. We're going from 5 to 10. So this one here, we don't have any infinities. So 5, 6, 7, 8, 9. And this one we are going to count out because it is going from 5. Now this one's going from 5 to 10. Don't overthink it. Okay, our solution set's lying from 5 to 10. What's 5 going to be, open or close? And what's 10 going to be? Okay, that's nothing crazy. And where are we going to shade this in between? We're going to shade this where? In between. Our solution set is from wherever the interval says, from 5 to 10. 5 is not part of the solution, but is 10 part of the solution? Yes, it is. So are we going to any infinities on that one? No. Now the inequality with this one, I'm building off of what you guys have done in 7th and 8th grade, so bear with me here. This is what we call a compound inequality. Now my Algebra 1 students are going to talk about this next week. The compound inequalities look like this. Okay? This is what our compound inequality looks like. Hopefully that rings the bell a little bit for you. We're going to have two inequalities up there. If I break this down, okay, this first one here, it's got to be below 10. X is less than 10. And then the other set of this has got to be, is saying it's got to be more than 5, greater than 5. And that's where we combine these two together. Now 10 you said was closed, so I also need to put the or equal to there, right? But in our compound inequality, this is how we're writing these up. Okay, now ideally you saw this in 7th and 8th grade. I'm not going to go through and teach you a whole new lesson on compound inequalities. We're just going to talk about it and go. If you understand this to this, I'm happy. I don't need you necessarily to remember all that compound inequality. But from here to here, that's all I need you to be at right now. Okay? So on the other one, what's the other one going to look like? Negative 6.5, bless you. And 7. Parentheses, no, we got brackets, right? So negative 6.5, all right, is close to negative 7, so open or close right there. Close, or sorry, close, you said. And then I don't care if it's exact. I'm just going to throw 7 all the way on the other side. And 7's going to be also close. I did not count these out. I don't care. We got the idea. What's that? Yeah, on the test would be more obvious for you. Okay, yeah. In this instance, let's just get it over with, yeah. And then again, this is a compound inequality. And every compound inequality that we're going to be we would work with, usually is going to appear like this. When they are in between, shaded in between like that, your inequality symbols are going to be read the same each time. Negative 6.5 is less than x, and it's going to be also less than 7, equal to as well. All right. Now we're back to the infinities. All right, and I'm going to drop down and do f real quick, actually, so we remember our infinities. So we're back to the infinities. So let's do f right below that. Back to 18 is 18 to infinity. So back to 18, 18, 18, open or closed. And which direction do we go based off that 18 to infinity? To the right, because we want positive infinity then. And when we say to the right, that means what type of inequality symbol? Excuse me, yes, greater than 18. Okay, nothing too huge off that. All right, last one there. How would you shade that last one? What's that? Shade the whole line. I want everything from negative infinity, don't stop, don't stop, don't stop, to the right, to positive infinity. So, as Yante suggested, I'm going to shade the whole line. Now, as an inequality, we've seen this written a couple different ways. In our books that we use, they use the infinity symbol in there. So what you could do is use the infinity symbol, but usually what we'll say it is, say it in words. What do I mean in words? All real numbers. Okay? The solution set is all real numbers. So every number you can think of. I shouldn't say because you guys can think of some different numbers. You work with square roots, they're not going to be in there. Square root 48 is not going to be in there. That's like irrational. Okay? So all real numbers. But there we go. Okay? We need you to make sure you're comfortable with using the interval notation here today, which is again, not usually anything too crazy, because we're going to use that then working with domain and range, and then what we call increasing and decreasing intervals. I don't know if it'll be Friday or not, but that's what's going to get into that. Analyzing our graphs later on Friday, Monday, and then next week. And that's where we wrap it up. Okay. Now, next week, Thursday, I'm going to give you one more mini quiz. So I'm going to pass out to you guys. 5x plus 6 and x plus, what was it, 8? Okay. 5x plus 6 and x plus 8. Again, the majority of you were completely fine there. One or two of you in my classes did the typical mistake where you put 5x plus 8, x plus 6. You had the general idea, but maybe in your head, you just got those flipped around. Check your guess. That probably was the mistake. You didn't check your guess. But then on the second one, you got that 5. So it tells me you got the idea of factoring. Keep checking those. Now on number 2, same thing on number 2. As you go through and check that out, 7x minus 9 and x minus 1. One more time. One or two of you might have got the first one right, but on the second one you flipped around x minus 9, the minus 9 and the minus 1. The signs, always check your signs. I don't think there's any issues on 1 and 2 there with the signs. Now on the back side really quick, number 3, that's where some of the signs I know from several people got flipped around. Now, the order of the quantities did not matter, but what was inside the quantities had to be exact. X plus 8 and then x minus 2, the order did not matter, but they had to be a plus 8 and had to be minus 2. What I saw from a few more people, again, typical mistake the first time through, a minus 8 and a plus 2, that cannot happen. 8 and 2 was the combo, plus 8, minus 2, that had to be the one that worked. Okay? Biggest mistake that I saw was number 4. Is that plus of GCF? Okay. What I saw number 4 is some of you brought out a common, but not the greatest common factor. 24 and 12. What is the greatest common factor for 24 and 12? Not 4, not 6. It is 12. Then some of you said screw the variable. The fortunate part is they both have an m in there, doesn't it? So what is the smallest amount of m's you can bring out? 1m, right? So some of you just brought out a 12 and stopped, and then you didn't bring out an m. Some of you gave me that as the answer, and then that was it. 12m, what do you have left over? Bring out a 12m, divide. 24m squared divided by 12m is 2m. And then a lot of you did that. Well, what's 12m divided by 12m? Something divided by itself is 1. So you should have had a minus 1 there. So if you see me wrote that and then another minus 1, it's because I've taken off minus 1 because you forgot that second term. I had a variety of mistakes I saw there, just a 12, not the 12m. I saw a 4 or 4m, and then you didn't bring out the biggest greatest common factor, blah, blah, blah. Okay? But first time through, it was fine.